Structure analysis is the effect of the load applied to the physical structure and its components. For engineering structure design, analytical structure is the most important thing to know. There are various structures that are related to the analysis. For instance, buildings, bridge, ships, and others. Therefore, this project has carried out a structure, namely a railway bridge, to analyze the strands of the structure. The purpose of this project is to increase students' understanding of the structural analysis, static, and mechanical of materials. Analysis of the internal and external strands of the member as well as structural deflections can be made through modeling and simulation on the application that have been provided such as LimPro and AutoCAD. Assalamualaikum warahmatullahi wabarakatuh. My name is Fatin Nabila binti Zulhisham, and for my part, I'm going to discuss on our design model using LimPro with following detail and the analysis results. Now I will show how to make this model bridge using LimPro and the analysis of the final results of our bridge. So first, we must set up the unit, which is kilonewton meter, then create a joint, and the length is 10 meter for overall. And for each member, the length is 2 meter, and the modulus of the elasticity for our bridge is 29 million, and the height is 2 meter. And then we create a member to this joint. For each support, we use pin support and roller support. Next, we must apply the load at the bottom, and the load is 20 kilonewton. And lastly, this is our design model for our final report of our analysis. And now I will run the analysis. So this shows the LimPro design model with distributed load. And this is the LimPro design model, the moment diagram, shear force diagram, an axial force diagram, reaction support, and the deflection line. The center span of the bridge was tested with 2000 kg load, which is 20 kN. The deflection at the center span of the bridge is negative 0.001782. By knowing the tension force and compression data, it can determine the analysis of the internal force of structure members. The tension force is 0.003284 at 827, while the compression is negative 0.001782 at 024. This table shows the LimPro analysis that state the internal force in member. Positive is tension and negative is compression. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and salam sejahtera. My name is Sophia binti Ibrahim, metric number AP900501. I'm the next presenter who would like to explain about AutoCAD. As we can see, there are 5 views. First view is 3D. Second view is dimension. Third view is floor plan. Fourth view is top view, and the last view is side view. Let's see the view of dimension. The overall of the leg dimension is 10,000 millimeter, and the span of edge supporting beam is 8,000 millimeter. Next, the contact of every base height and width is 200 millimeter. Because the center is 8 millimeter, this part and this part is only 100 millimeter, so the total is 10,000 millimeter. This part, and this one is top view. This one is top view. This line is roof, and this line is float. This one. So the last is side view. This line is base contact. This one point load. That's all from me. I will pass to the next presenter. Thank you.
Hi, my name is Nadiliana binti Anwar. So I will continue my part about manual calculation. Okay, first we use 20 km per meter to overall of length of the bridge, which is 10 meter. To determine the point load, we need to multiply 20 km per meter with 10 meter to get the point load, which is 200 km. Next, we go to the calculation at two support, which is spin and roller support. For the roller support, the reaction force is positive, 100 kN in FY direction. And also at pin support, we get positive 10 kN in FY direction. Reaction force at pin support in AX direction is equal to 0. Next, we use method of joint to calculate the value of internal force for each member. So first, the internal force at member AB, BC, CD, and DE, we get 100 kN, which is tension. Next, the internal force at member AH and EF, we get negative 141.42 kN, which is comprehension. For the internal force at member CG, we get 200 kN, which is tension. Next, the internal force at member CH and CF, we get 141.42 kN, which is tension. At the member of FG and GH, the internal force is negative 200 kN, which is comprehension. And the last one, at the member AI, BH, DF, and EJ, the internal force is 0 kN due to 0 force member. So now we go to determine of thrust. So the formula is M plus R equal to J. So M here is 13, R 3, and J is 8. So 13 plus 3 equal to multiply by 8. So the answer is 16 equals 16. So the statically determinate or stable. So this is the calculation to determine the reaction force for both support, which is spin and roller support. We use some moment at A to get reaction at E in F1 direction, which is 100 kN, and some F1 to get reaction at A in FY direction, which is 100 kN. We use some AX to determine the reaction of A in FX direction, which is 0 kN, and we do calculation at joint A, joint B, joint H, joint G, joint C, joint D, and joint E. Next, we do a comparison between manual calculation and LiPo software calculation. We divided into 4 columns. The first column is member, second column is LiPo calculation, third column is manual calculation, and the last one is the different percentage. So, this is the result we get. That's all for me. Thank you.
Based on the bridge project, There are some recommendations that will be discussed. The rigidity parameters of the girders, slab, shear connectors and bearings are changed in the initial construction model so that the friction properties of the model match to the measurement data. Besides that, we might improve the bridge longevity by increasing the thickness of the members. However, the result illustrates that the bridge load capability in current condition is lower than the under specification condition, yet it is still higher than the design criteria. A beam is the structural component of a bridge that resists load applied to its axis. There are three materials that use as beam base, which are steel, concrete and wood. In this case, we recommend that the base be concrete, specifically reinforced concrete, due to the location uses of the bridge in issue, which is a railway bridge. This is because despite steel is known to be a very solid base, this particular beam is used frequently by the train, and the fact that steel is a high maintenance material will require the use of extra jobs for regular painting. A column is a vertical support structure which is used to supporting a bridge part. In addition, a column can be made from wood, concrete or steel. Beam column joints are major element of reinforced concrete structure. The railway bridge requires strong columns for support in this situation. T-shaped columns are the recommended shape due to it has a high strength and good seismic performance. A post like a column or pillar is a main vertical or linear support in structure. The term of post usually refers to timber, but it can also refer to metal or stone. Besides that, the post structure that has been applied to this bridge is triangle shape. Triangles are one of the greatest shapes for distributing weight. This is because it can take force from a single point and distribute it when across a wide base. When a load is applied to one of the triangle's corner, the force is distributed down each